Alright, so in this video I've got my last example of solving trigonometric equations, and in this video I'm going to feature an example in which I'm going to use the squaring property. So I've got cosine x equals sine x minus 1, and I want to find all the x values that make this true on the interval from 0 to 2 pi. Again, the same as the last two videos, at any point if I'm on a calculator section, I could either graph these two separate functions and find their intersection, which is where they would be equal, or I could set this equal to 0 by moving some things to the other side and find the roots or zeros on my calculator. If I need to solve by hand, all the strategies that we've gone over so far don't seem to work for us. We don't have like terms, so I can't just add sine or cosine together and isolate one trig function. I also can't factor out something common if I set this equal to 0, or use the quadratic formula or the box method to factor. So I'm left with the squaring property and squaring both sides to help me out to solve this. Just remember that anytime I square both sides of an equation as a way to solve, when I get my solutions at the end, I have to check for extraneous solutions that may have been produced. So I'm going to square both sides. Let's see what happens. I end up with cosine squared on this side. On this side, if you need to expand that by setting up a box, you can. And we'll end up with sine squared minus sine and minus sine x, which is negative 2 sine x. And a negative 1 times negative 1 is a positive 1. So sine squared x minus 2 sine x plus 1. Great. Okay. Now, I've still got different trig functions going on, but luckily using my trig identities, I should be able to change cosine squared to something with sine squared. So remember that sine squared plus cosine squared always equals 1. So if I want to rearrange this a little bit, then I could say that cosine squared is always going to be the same thing as 1 minus sine squared x. Okay, so I'm going to go ahead and rewrite that left-hand side, and for now leave this one the same. So now I've got some like terms that I should be able to combine on either side of my equation. So I'm going to go ahead and start moving these things over and setting this equal to 0. So I'm going to subtract 1 from both sides, and I'm going to add sine squared x to both sides so that I set this equal to 0. Sine squared x plus sine squared x would be 2 sine squared x minus 2 sine x, and a positive 1 minus 1 would be 0, so I won't have any constant term. Alright, and now I'm pretty much back to what I did in the previous two videos with factoring, and I have a polynomial type equation here. So I'm going to look, and I see that I've got common factors, so I'm going to use my strategy of factoring out the 2 sine that these both have in common, and that would leave behind a sine x minus 1. And now I've got 2 factors, and I can use the zero product property to state that either 2 sine x equals 0 or sine x minus 1 equals 0. And I'll go ahead and solve for those trig functions. So dividing by 2, sine x is either 0, or adding 1, sine x would be equal to 1. And let's think about at what angles that would happen. And think about sine, so my y values. Now y would be 0, not going up and down at all on the sides of my unit circle here. So at 0, pi, and 2 pi. So 0, pi, and 2 pi would be my solutions from this one. And where is sine 1? Where is y1? That would be going up 1, so right here at the top. And let me label those so we can see. And that would be pi over 2. So I have pi over 2. So my solutions so far are 0, pi, 2 pi, and pi over 2. Now if you would have used the graphing strategies that I mentioned at the beginning of finding the intersection or the roots, you would see that these actually are not all solutions. You do not see 4 intersections or 4 roots when you do that. And that's because we might have extraneous solutions. So when we solve a problem using this method, we have to go back to our original equation and plug in these values and see if it makes the equation true. And if it does, that's going to be one of our solutions. If it doesn't, we're going to throw it out. So let's go ahead and do that. Let's say cosine of, let's check the first one, 0. Does that equal sine of 0 minus 1. Well, cosine of 0 would be back over here. Cosine is 1. Sine of 0 is 0. So I get, does 1 equal 0 minus 1? No, 1 does not equal negative 1. So that is not true. So I'm actually going to throw out 0. Okay, let's try the next one. I've got cosine of pi equal to sine of pi minus 1. Cosine of pi is negative 1. Sine of pi is 0. So negative 1 equals 0 minus 1 is negative 1. That is true. So I'm going to keep pi. Pi is a solution. Okay, let's try the next one. 2 pi. Cosine of 2 pi equals sine of 2 pi minus 1. That's back here where we just were. So I end up with, again, 1 equals 0 minus 1. So 1 equals negative 1. Not true. Throw it out. And last but not least, cosine of pi over 2 equals sine of pi over 2 minus 1. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. 0 does equal 1 minus 1. So that one we're going to keep as well. So my final solutions would be x equals pi and pi over 2. There are 2 solutions to this trigonometric equation on the interval 0 to 2.